I picked this topic for building up AI capability cost effectively, which I think will resonate well with you guys, yeah, as a startup founder. And yeah, before I start, I normally like to just tell a little bit about myself to give you a bit more context why I do make certain decisions, why I'm so passionate about these specific areas. And this is me. I see myself as like this nutty professor. I really enjoy technology a lot. Yeah? And the reason why I really like technology is because technology gave me this like a extra human capability, like beyond human capability. You can do more with technology than what your physical constraint limitation, right? And I actually not just use technology at work, but also as part of my hobby, I like to build technology gadget at home as well to entertain my family. And this is my wife and at that time he was like 3.5 years. His name is Dexter. And yeah, like I said earlier, I like to build all kinds of toys for him. Yeah, at the same time looking after him, I'm also entertaining myself building this technical gadget, right? So just like about 3 years ago, I built this this AI that actually helps my wife to answer her most difficult question that she throws at me every morning when she wake up. You know, what should I wear today, Gus? You know, this is a really hard question for me because I'm not really fashionable, right? I have like a 4 or 5 type of t-shirt, you know, that I wear in rotation. And yeah, so it's a really hard problem for me. So I decided, okay, why don't I build an AI for her, right? I'm actually utilizing a deep lens, AWS deep lens that I put in front of my on top of the cabinet facing the front door when she exits the house. And whenever she exits the house, this deep lens will actually detect her presence, capture the photo of her wearing the clothes that she's wearing at the time, record the weather on that day, yeah, and put it in a database somewhere in the cloud. And then at the same time, actually build an application on the mobile phone, yeah, that she can actually browse through to check all the photos that's been captured in this fashion diary with the weather condition. So my hope is actually for her to be able to see what kind of clothes that she wear on that day, what kind of weather that was, right? To give her a bit inspiration what to wear today, right? Actually quite successful project. Yeah, she asked me less now, right? Which is good. Self-serving herself. And another project that I built recently as well is called Griffin. This is actually to entertain my 3.5 years old son. Yeah? It's a flying simulator that I built for him. So he can control this 3D bird in the 3D world using only his body. Yeah, it's like a motion capture, really. Yeah, but that is actually kids friendly. So it's very simple. Again, just using a camera connected to an AI model that detects the movement of his body, and then I connected to a 3D game engine which render the game's engine plus the bird flying on top of the mountain, right? So yeah, so just those are the 2 examples of the project I built. But you know, today the topic is not about these toys. Yeah, we're talking about something more serious, right? So now I'm going to step up a bit to introduce you the company that I work for. Yeah, so to give you more context of the story that I'm going to tell you today. Yeah, so I work for Car Sales. It's actually an automotive portal in Australia. The headquarters in Australia, and we actually have a portal that facilitates car buying and selling. And we have both private and dealer car. And at any given time, we have around 160,000 cars, with around 3,000 cars coming in every day. Yeah. And apart from cars, we also have other vertical bikes, boats, trucks, caravan, and anything with wheels on it. And we have a presence in many countries, like in Latin America, Brazil, Chile, Argentina, Mexico, and South Korea, and recently America as well. And a few of the AI tech that we built at Car Sales, one of them is the one actually really enjoy building the most. It's called Cyclops, car recognition that actually can identify your car make, model, body down to the trim level just from a single photo. And this AI also able to track the movement of the car on the street in real time and identify it within less than a second, right? As you can see in the upper right corner of the screenshot there. Yeah. So we use this AI to automatically identify the car that you're selling without the need for you to tell us what car you're selling. We know better than you, right, from the photo only. Second AI model that we built is called a Mystic. This is an object detection model that detects the presence of a regio number in your car photo and blurs them automatically with the intent to protect your privacy. Because in Australia, and I believe in many other countries too, there are a lot of criminals searching for a photo of car on our portal that's similar to what they have, yeah, and then crop the ratio number, stick it into their car, and then commit all kinds of criminal activity. Yeah. So we use this technology to protect our seller. Yeah. So apart from these two AI, there are many other AI that we have. Yeah. So one of them is automatic advertisement approval. They automatically approving the private seller ads. Also a recommendation system, yeah, to recommend a car that most likely you will want to inquire. So all of this AI that I mentioned today, just now, it's all highly scalable. And one of the AI, like the ratio blurring mystic, is even processing around like 500,000 of photos a day. Yeah, so you can feel that is the scale of the AI capability that we're doing in car sales. And even though we are a big enterprise, yeah, we have more than 1,000 employees worldwide, and yeah, generating revenue close to $1 billion a year, right? We have a very startup mindset, yeah. And the reason why is because we want to build many things. Yeah, we are full of excited people, very passionate people wanting to build so many cool features to actually improve our user experience, customer experience, because we want to build so many things, yeah. And budget is become very tight. Yeah, of course, we are not like a Google, Amazon that have maybe a lot of money, right? So our budget is actually have some constraint there, right? So because of that, yeah, very often a person is actually wearing multiple hats. Yeah, so ML engineer also wearing a data scientist hat. Software developer sometimes also wearing a DevOps hat. Yeah, so and so on and so forth, right? So efficiency and cost saving is very important, right? So I hope with this actually set a tone and will resonate well with you guys. As a startup founder, I know your budget is tight. Yeah, you really want to try to maximize your throughput with the small cost, as little cost as possible. So now, before I continue on, yeah, I want to actually just give you a rough idea. What does the ML machine learning development lifecycle looks like? This is what it looks like at car sales, and I hope most of you also resonate to what this means, right? So the first part of the machine learning development lifecycle is always start with experimentation, and normally conducted by a data scientist, which starts with building the AI model, getting a small data set, experimenting with many different type of model, hyperparameter tuning, until they find the best hyperparameters and the best model architecture that deliver the requirement, right? And once they are completed these steps, yeah, we start productionizing the AI model. So you handball it to the team there to productionize the model, which mainly is done by ML engineer, right, with a little bit of the help from the data scientists. First, they will build the continuous model training, because probably like 90% of the AI model you build, you need to actually train them. You need to actually refresh the model once, maybe daily, or I don't know, like weekly, depending on the requirement, right? So it learns from the new trend of the data. And this continuous model training will, of course, at the end will actually produce a new model that you need to deploy, yeah? And the model deployment will need to deploy the model into a form that actually can serve the project requirement, yeah? And one of the popular deployment mechanism is deploying it as an API, right? So your mobile application or web services can actually call the API to make an inference. And of course, the model monitoring to make sure that the model actually perform well, yeah, and keep performing well. And if it is not, at least you know for you to jump in and troubleshoot. Yeah. So this is what the machine learning development lifecycle that's happening at car sales. Yeah. And in order to actually conduct this exercise from end to end, yeah, you will need an ML platform and tools. Yeah. And now let me continue the story further, just to give you a bit more history. How does AI actually was born at car sales, and the journey from there onwards until today, and what challenge that we're facing, and how do we actually solve them cost effectively? Yeah. So in 2016, yeah, this is the birth of AI at car sales. Yeah, there is no AI team, there is no data scientist, there is no ML engineer prior to that. Yeah. So in 2016, there is a small team called AI team. Yeah, that's a team of only 3 people. Yeah, they're actually building all of the AI end to end at car sales. Yeah, so even prior to this 2016 and 2015, this is actually just a team of volunteers from various parts of the business, including myself, which is spending only 1 day a week trying to prove that AI has a value to the business. Yeah. So we are given 1 day a week to work on AI project. And luckily, we successfully deliver business value. And the AI team was formed in 2016. Very small team, like I said, 3 people. That building AI for the entire company. Yeah. Starting from the experimentation, acting as a data scientist. Yeah. And then productionizing the model, acting as an ML engineer until it is consumed by the respective development team who requested the AI technology. And in 2018, there is a new data science team that was formed. Yeah, again, it's a small team of less than 5 people. And this creates a second workflow. Yeah. Instead of AI team building everything from end to end, now the data science team is also helping building the AI model, yeah, conducting the experimentation. And with the help of the AI team, actually, the data scientist will productionize the model. And over time, yeah, the demand of building AI technology is actually increasing at GasSales. Yeah, as we've proven there is a value, we deliver more success, the business starting to invest more, wanting the many stakeholders starting to believe in AI. They start asking and knocking our door. Can you build this for us? Can you build that for us? Right? Now here is the issue. We are becoming the bottleneck because these 2 teams are very small team. Yeah, it's a team of less than 8 people. Yeah, what is the solution? Right? Of course, yeah, hire 100 data scientists and ML engineer, right? Yeah. Well, that's not really the right solution, right? So we believe there is a better solution to this, yeah, which is through process and structures, and also using platform and tools. Yeah? You can have a better solution that's more cost effective. So what are the solutions? So in 2022 onwards, right, we want to create 2 new workflows. So with the workflow number 3, yeah, the data scientists can actually pair up with any software development team within GasSales. And there are like 15 software development team at GasSales. Yeah, total about around like 80, 100 software developer in total. Yeah, this is just the software development team in Australia alone. Yeah, not internationally. So this way, data scientists can actually get the help from development team who requested the AI tech to be built, acting as an ML engineer, right? And with the workflow number 4 is even more drastic. We actually can get the development team themselves to actually build the AI tech from end to end, from experimentation to productionization. And because we have hundreds of software developers and they're all eager to learn, this is where the skills can come from. Yeah. So, like I mentioned earlier, right? What it really means is, yeah, if you look at the workflow number 4, yeah, we are actually turning our software developers into a citizen data scientist and also into a citizen ML engineer, right? And really, what the structures that actually we are building here is actually a decentralized structure, yeah, where inside in the middle there is a hub here, yeah, the data science team becoming the hub of data science skills, and the AI team we turn it into an ML platform and engineering team, acting as a hub of ML engineering skill. And this hub is connected to all of the development team, which we upskill them with a little bit of data science and a little bit of ML engineering. Yeah, so to actually make this strategy works. So, like I said earlier, the hub responsibility will be to provide data science and ML engineering enablement, educating everyone, running a workshop, yeah, teaching people how to do it, giving a guiding hand, providing the central governance of the ML engineering and data science, and also building a shared tools, yeah, for everybody to use, and also to build and maintain the ML platform, which is the job of the ML platform engineering now. Yeah, half of the job is building this platform. Yeah. All right. So it looks pretty. Yeah. It looks like it's a great strategy, but any strategy always comes with challenges. Yeah. And these are the 2 big challenges that we face. Yeah. First, how do you actually democratize the data science skill? How do you equip your software developers with a data science skill to perform experimentation? And how do you do the same thing for productionization? How do you democratize the ML engineering skill? And in order to actually to solve these two problems, yeah, one of the big key component is actually the ML platform and tools, which is the thing that we need to have, yeah, in order to have this strategy to be possible, yeah. So this is why, and this is where the Amazon SageMaker ecosystem comes in handy, yeah. It's actually a very awesome ecosystem which let an organization with a less data science skill and less ML engineering skill, but has a lot of software development skill, yeah. And again, if I go back to this diagram that I showed you earlier on machine learning development lifecycle, yeah. So these are all the diagram that you've seen earlier, right? And now this is where the Amazon SageMaker ecosystem will actually take place, yeah. So it will actually provide you with a platform and tools to enable end-to-end of the development lifecycle of machine learning. And now I will start going deeper into like what does it mean, yeah? How does the Amazon SageMaker ecosystem help you during experimentation and during productionization? Let's start with the experimentation. Yeah, how does it really help you? Well, you know, as I'm very sure some of you are aware of the data scientists actually love the Jupyter Notebook, yeah, to conduct experimentation. And a lot of the data scientists that I know run a Jupyter Notebook in their own laptop, right? Which is really not scalable. Yeah, if you crazily want to build model that actually big, your laptop's going to be burning, right? And you cannot even do a hyperparameter tuning, running a training on multiple models at the same time, right? So you are bounded to the limitation of your laptop. So with Amazon SageMaker Studio, you can actually start your Jupyter Notebook in the cloud. Yeah, it is like a supercharged notebook. You can run multiple notebooks at the same time as a different tab. Yeah, and you can even like train your model not in the notebook instance itself. Yeah, your notebook is running in an EC2 instance, but when you train, you can actually offshore it to the another instance where Amazon SageMaker actually being trained. Yeah, so it's not trained on your notebook. That way you can run multiple training sessions at the same time. Yeah, very scalable. And the good thing as well, then you can also version control your Jupyter Notebook because it has a GitHub integration. And another awesome thing about the SageMaker during experimentation actually helps you to now solve the democratization of data science skill. And the reason I said this is there are like many SageMaker built-in algorithm that's ready for you to use. Yeah, so this is the model that actually super easy to use that can solve various problems. Like the one I show you here, there is a random cut forest, there is a sequence to sequence, there is XGBoost for decision tree, there is image classification if you want to build the sausage or no sausage in a photo, right? So there are many of these algorithms that are ready to use, and you do not need to actually know the data science behind it. You do not need to know how to build it, right? As long as you know how to prepare the training sets, yeah, what are the expected format, and how to evaluate the model, that's all you need to actually use this algorithm. So with this, the democratization of data science skill is now already completed. Yeah, you do not need to know a lot of data scientists. Yeah. So now, taking it a bit further, another useful features in SageMaker, yeah, that actually helpful during productionization and also during experimentation is a SageMaker model registry. And at car sales, we use this a lot. And the reason is why, if you're starting a startup with only like one or two data scientists, then maybe it's okay, yeah, because only these two people actually building the model, right? But at car sales, there are like a 25 team, and a lot of them can be building their own model. We want to actually encourage model reusability. When somebody builds a model, yeah, another team we do not want other team to build the same model that's already being built by others, really. So model registry help you to register your model and also archive the metadata. And this model can be searched through the search interface, yeah, that you can see here, search column name. Yeah, so you can actually search through here to search the model that actually you want, and you can read and find out more information about it in the metadata to know whether this is the model that actually you need. So this way actually encourages the model reusability. Very handy for a big organization. Even if you are a small organization or only a few people, it's handy to actually archive your experimentation. Yeah. So speaking about this a bit further, the model that you register also have a version and have audit trail. You can register many versions of the same model, yeah, and you can even moderate this model as well. Which one you approve, which one you rejected, yeah. You can moderate it in the UI directly, yeah. And the most important thing that I feel is very, very useful is the metadata that was archived. Yeah, it's also archived the training sets. Where is it coming from? Which is very often you've forgotten. This model that I built just like last week, it was super awesome. You know, it's that with has the best accuracy, but you've forgotten where's the training sets. So you cannot really reproduce this model very easily, right? So now let me continue on the productionization. Yeah. So how does a SageMaker ecosystem help you with productionization? So like I said earlier, the two big components in productionization is building the continuous training model, yeah, and the second component will be the model deployment and serving. Yeah, with the first component, right, building continuous model training, you need something like an orchestration tool. You need a platform that allow you to actually have like a multiple blocks. Define a block that got executed after another block. Yeah. So the first block is extracting data, the second block is transforming data, the third one executing training, and the last one may be doing a validation. So this is what normally what happened during the continuous model training. It's not just training the model, but also getting the data, preparing it, training it, validating, evaluating the model, right? So at car sales, we use Metaflow, yeah, because back then SageMaker pipeline wasn't there. Yeah, it's not out yet, but you can also use SageMaker pipeline to actually replace Metaflow here. And many other companies probably also can use other platform like MLflow, anything with flow in it. Yeah. But yeah, the talk today, I'm going to emphasize on SageMaker pipeline, yeah, because it's ready to use. It's in AWS ecosystem, straightforward to use. Yeah. And now talking about the model deployment and serving, yeah, the SageMaker ecosystem also help you significantly. You can deploy, register and deploy your model for inference very, very easily. I'm going to show you in the next few slides. Yeah. But now let's go back and talk about the SageMaker pipeline. Yeah. So this is what the SageMaker pipeline looks like. Yeah, visually. Yeah. Like I said earlier, your continuous model training consists of multiple blocks, yeah, multiple steps. So you can define these steps by code, and you can visualize them through this like a very pretty visual interface. Yeah. And you can see all the parameters for each step. So you can think of this as like a CI/CD for machine learning, yeah. So and yeah, so it's very, very handy. Yeah? And at the end of the model training, to deploy the model, it is super easy. Like the code that I show you here is actually the code that actually we use to deploy the model using SageMaker Python SDK. It's only one line of code. All you need to know is just like the TF estimator is actually your training session, yeah. And then .deploy is a method, and then you just need to specify what is the number of instances you need and what is a type, which in this case is C5X large. And as you can see, there is no ML engineering skill that needed here. Yeah, everyone know how to do this. Yeah, especially if you are a software developer, this is no brainer for you, right? So with this, our democratization of ML engineering is already completed. Yeah. So now to talk about the SageMaker deployment and inference a bit further. What we really like about the SageMaker deployment is it does not just give you one way of deploying your model, which is, like I said earlier, the common way is deploying it as a REST API. So you can consume this API from various services. However, there are many other types of deployment here in SageMaker. So like the one I mentioned to you earlier with REST API is called real-time endpoint, yeah, where the endpoint is ready for 24/7. And you can call this API right away, get the response right away. It's a very good way of serving the model if you really need a very, very fast response time. Yeah. But if you do not need a quick response time, you actually can deploy your model as a batch inference. So what it really does is you call the model with like a 1,000 or even millions of like inference data to make prediction for all of this data one by one automatically. Yeah, but you do not require the result to be given to you straight away. Yeah, you can wait for like a 2-3 minutes or 5 minutes. Does not really matter, right? So this is a very cost-effective way of running a batch inference, because what it really means is you do not really need to deploy your model into as a real-time inference 24/7, which what it really means is you are paying every hour the endpoint running, right? Even though you do not call it. With batch inference, you only call whenever your model is executing the batch inference. When it stops, that's it. You do no longer need to pay. Yeah, very cost effective. Serverless is actually a new capability that AWS deployed just, I think, last year. Yeah, so which is very cool. It's like you do not even need to actually deploy the model as a real-time endpoint that you're paying 24/7, but all you need to do is you just pay per call. Yeah, so very similar to serverless Lambda. Yeah, so very handy if you do not have that frequent call to your model. However, an instant response is required. Yeah, so of course, if you end up calling it like making a million calls an hour, you're still better off with real-time inference, because as you know, Lambda is designed to be very expensive if you call it very often. But if you do not call it often, then it's actually beneficial, right? So, and many others that are asynchronous, and there are a couple more which I cannot remember. You can go to the documentation of SageMaker to find out what they are. Yeah, and another beauty about SageMaker is it has a built-in model monitoring capabilities. Yeah, so deploying a model is one thing, but making sure the model is running properly, yeah, in the next 2 years is another thing, yeah, altogether. So having this capability built in is very useful. So you do not need to build your own monitoring tools, right? So yeah, so now we land to my last slide here to wrap up. So what I really want to emphasize here is building AI capability does not always equal to very expensive dollar investment. Yeah, and make sure that you enable your existing team. Software developers are smart people. They can learn anything as long as you give them time and they are passionate enough and you give them the right tools to do the job. Yeah. And what I mean by tools is leveraging tools that already out there. Yeah. So give the SageMaker ecosystem a go, and this will make a very big difference, yeah, in your organization. And even though you after doing all of this and you discover, oh, you're so easy, everybody in my team can do this, don't forget one thing. Yeah, it's not about deploying the model, but also making sure that actually your model performing well, and also you evaluate the model. Sometimes it's very easy that we fall into a trap that, yeah, we use SageMaker, build an algorithm, train the model. SageMaker say accuracy is 95%. That's good enough deploy. Yeah, so that don't fall into that trap. You have to understand how to actually evaluate your model. Yeah, even though it says 95% accurate, make sure your model training set's actually balanced. If not, if it is even though it's balanced or not balanced, you analyze your confusion matrix. So spend a bit more time to understand a little bit of how to evaluate the model, right? To make sure that you are really using the tools properly. Yeah. So that's it. And thank you for listening. And if you want to reach out to me, you want to know more about the project that I built, you can go to my LinkedIn. You can look at my GitHub account, and also a blog that I actually wrote in Medium. So I think now it's time for Q&A. So anyone have any question, feel free to ask.
Hi, so I had a question. So I was thinking that, okay, the main goal in all this activity is to make it easy for the teams, for everyone in the team to use ML tools and stuff like that. But like in your experience, maybe it's not, it's more of a, not a technology question, but like in your experience, what happened, like did you observe that, okay, the quality of ML models, or like the cutting edge deep level research kind of stuff that people were doing, that got diluted a little bit as well, because like the entire team composition itself became much more like everyone knows everything kind of stuff, instead of being very specialized into, some people being very specialized into cutting edge stuff.
That's a good question. So this is maybe an extra context that I can actually provide. So we found that in the past 2 years when we execute this strategy, yeah, 70% of all of the ML use case, the ML problem that we need to build a solution for, does not require specialization. It's actually a very simple one, like detecting the intent of whether the sentiment of the inquiry, yeah? Detecting, classifying the angle of the photo of a kind, classifying the angle of a guy in the photo, yeah, whether it's dashboard or side or is it front, and this 70% of the use case, we find that actually we do not really need a data scientist, really, because it's super easy, and all you need to do is just a common sense and understanding of the domain knowledge of that particular problem, right? Which mainly you do not need technical knowledge. All you need to know is the domain expertise, like in the area. So this 70% is easily you can actually give away to any software developer, and you will not actually make any big difference if you give this job to a data scientist. Maybe data scientists can do a little bit better job, like another 3%, 5% more accurate, but the trade-off like between the cost and value is actually not that good, because you are now having to actually bombard all your data scientists with all of this like a very easy job, right? While the other 30% of the problem that we build really require a data scientist, and most of them actually require building the custom algorithm, the algorithm that is not really available in SageMaker built-in algorithm collection. So with this kind of like distribution, essentially we find the right balance. Yeah. So we give the easy job to the software developer, but we give the hard one to data scientists. So we're not sacrificing quality because we give the easy one to the software developer, right? And of course, maybe your follow-up question would be like, how do you know which one is easy, which one is not, right? So that's the job of the hub, the data scientist hub. Normally jump in at the first call of when the project requirement is actually delivered by the stakeholder, and they will assess, oh, this is actually quite easy. Yeah, we do not need us. We will actually handball it to the respective development team under their guidance. Sometimes they still need to jump in to give a bit more guidance, but the development team, they have already done it like 3-4 times. They do not need to actually have more guidance anymore in the future because they're already familiar with that. Hopefully that answered the question, Shalab. Yeah.
Yeah, thank you. Thanks. It did.
Hi, guys. So I really liked the project regarding the suggestion of dresses based on the weather condition and stuff like that. So were you doing in some sort of a image image search or something like that within the all the looks that were created based on what your wife was wearing, right? So was there any sort of a visual search involved? How did you tackle that? Would love to know about that.
Okay, so if I understand the question correctly, what technique do I use to actually analyze the clothes and provide recommendation based on the history? Yeah,
correct.
The question?
Correct. Yeah.
Okay, so you asked the right question, because there are two big components of that project. First is actually to detect the presence of a human at the front door, and to take a photo and to recognize whether it is actually my wife. Yeah, because I do not want to record myself. I do not want to record my in-law. So correct. And so those are one component. But the second component, actually, once the photo already in database, there is a component actually running in the background, indexing all of the photo, and then crop just the area where the cloth is, and then generating some sort of like a fingerprint out of every cloth. So like this cloth that you wear yesterday is the same as the one actually 5 days ago, right? And once you already generate this index, so you know which cloth actually being worn by when, those become your inventory that you can use to actually being recommended to my wife in whenever she uses the app, right? So the technique that I use there is quite simple, and now, honestly, it does not really work very well at the moment. Yeah, accuracy of actually, even if you take a step back, not even recommending, just actually tagging this cloth is the same as this cloth that you wear 3 days ago, the accuracy of such tagging is currently only like 60%. Yeah, and part of the reason is because of like it's so many factors, like the cloth can sometimes wrinkle, sometimes you carry like a lot of like a shopping bag, So all of these factors make it so hard to actually detect that clothes, like to recognize this clothes is the same as the other one. Yeah, sometimes two different clothes, right? They look the same and at night because the lighting is very poor. Yeah, and being lots of like object actually covering the clothes as well, right? So that one is around 60%. But then the recommendation is actually quite simple. It's just simply using the if she wear this at this specific weather condition, most likely she want to wear it if today the weather condition is similar, right? So it's just very simple, classification model, really. Yeah, that I built. But of course, the recommendation system does not really work that well because of the tagging itself is only 60% accurate, right? Yeah. So hopefully they answer the question. Yeah. So it's not production ready. Yeah. But if you are curious, reach out to me in LinkedIn. I can share you the link in GitHub where the code is. Yeah.
Sure, I'll definitely reach out to you for that. Yeah, thank you so much.
If you do not mind, I have a question for you all. If it is okay, Pratik.
Sure.
I'm curious. Any one of you guys startup that actually work in the computer vision? If you can raise your hand.
So we do like so computer vision is like a part of what we are building, right? So again, we are in a similar space where we are recommending products to different people. So to understanding what product is in the frame and stuff like that. So that's where we are currently working with. But our algorithm is currently mainly a text based on the description and other attributes that I mentioned. But we are experimenting with computer vision and exactly the problem that you told us about, where there's a lot of noise in the background or different other elements. That's what is that's where we are also working to solve these kinds of problems.
No wonder you asked that question. But with your particular problem, is it like is the object actually very easy to recognize? For example, it's a common object, like it's like a drinking bottle, it's like a headphone, or do you need to actually detect if it is a drinking bottle, what kind of texture, what kind of shapes?
Currently, we are so in terms of whenever we are working with fashion and stuff like that, their pattern or color makes a lot of sense to recognize, right? So, for example, whether it is a blue shirt or a white dress, it is very important to identify what that is. But identifying color out of a picture, because there are multiple colors from the backgrounds or even objects in the foreground, but do not matter to the product also are there. So, for example, the model is wearing a dress, but is also wearing a bag. Right. So that would, what color to prioritize on, even after identifying the exact object. So we first need to identify the product, whether it is a dress, and then crop out the dress and then identify the color of the dress. So that's the pipeline kind of we are trying to understand and kind of stuff.
The technique that actually I use, that's the exact problem that actually I face with the clothes. I need to know what type of clothes it is. Is it jeans? Is it shorts? Is it like a gown? And if it is, and then what type of gown, and then also what is the color and texture. So there is a technique that I use. It's called neural style transfer, so that you can actually extract the fingerprint out of the texture, the low level details and the high level details separately. But the challenge with this technique is actually for texture maybe okay, but for the actual shape of the cloth is really hard, because cloth is very, very soft material, so it deforms very easily towards your body posture. So you probably need like a much more advanced technique to normalize the posture of the human body that wearing that clothes.
Correct. So in pose estimation or something like that might be needed to implement from our side. To, identify and correct the posture or correct the shape of the dress, maybe.
Exactly. There is a research paper that I read. I think it's done by people who released the fashion MNIST data sets. And that research paper is actually showing how you build a neural network that you pass in the photo of the person wearing the clothes, but you also pass in the posture that was detected by the open pose into the model. So then the neural network now know how to normalize that photo, the clothes photo, against that posture. And at the end, it actually produces a better fingerprint of the clothes, because it knows the pose, just a photo of the clothes, So I think it's fashion MNIST data set that the people behind it released this research paper.
Sure, I'll reach out to you in that case, that get the name of the paper and stuff, because I know about fashion MNIST, but it is very, very, very simple when it comes to fashion MNIST. But the other paper might be much more advanced, I guess.
So in our modules, we have got we are tagging for multiple computer vision elements, like we are identifying celebrities or known faces. So we have trained the model for known faces, We are also identifying unknown faces which are getting clustered as unknown 1, 2, and then on the local machine can then be trained. So on the face side, we have known faces that are tagged from our list, and then there are unknown faces that are clustered. Then we have emotions. We have 12 emotions which are being identified, both extremes. So we have happy and laughing, sad and crying, and a few neutral emotions as well. So we are identifying that. We have prepared multiple classes of objects, and it's an ongoing list similar to faces. And we are training for each class. For example, we have musical equipments or sports equipment or home items, office items. So we have multiple classes within objects which we are identifying. The critical ones that are being used are identifying cigarettes or ashtrays or hookah or a wine glass or an alcohol bottle. So these help us on the content moderation side. And multiple other things in computer vision like short segregation, identifying types of scenes, actions. So more or less all of this in computer vision.
That's a very interesting use case. Content moderation is one of my favorite. As we are watching the screen more often, and my kids also watching the screen too, it's very important to have content moderation.
Gus, I had one more question.
Yes.
Have you worked on anything where the image quality identification in terms of not just whether the image is having good amount of resolution or something like that, but more like whether the image is aesthetic or not, or whether the image is can be showcased as a cover of something or not? Have you worked on anything like that, and what can we use to do that?
So we have something like this at car sales that we built, but we do not use AI model actually. Yeah, we use AI model, but not like you passing the whole image to AI and then the AI to tell this is not good. Right? So we actually compose the solution from various AI model. So maybe to give you a bit more context, what we do is actually we check the photo, the video that we recorded by our private seller of the car, yeah, and we want to be able to say, okay, this video, your car is not in the frame, it's a bit offside, a bit cropped, right, and the angle is not good, yeah, because we normally when you take a photo, record a video of a car, it's good to take a little bit from the top angle so you can see a bit more like a bit more coverage vertically, not just like flat from the eyesight, yeah, from the height of your head, right? So what we do is very simple. Like I said, it's just simply using object detection to detect where the car is, right? And also we're using image classification to detect where is the angle of the camera that was taken in reference to the car. And based on that, we actually have some logic to say, oh, if it is off center, the angle is not that good, it's too low, not high enough, then we actually produce a message and tell our user, hey, this part of the video is not great, right? And we also can rank the video to the video that has a better ranking. We actually show it first, yeah. But again, like I mentioned earlier, this is just a very simple composition of several simple AI model, and on top of that, you use a rule-based engine to make a decision what's good, what's not. Right? But if what you're referring to is like a very smart AI model, you pass in a video that suddenly just come out with the answer, this is not good, yeah, because of blood, because of ABC, then no, we haven't done it that far yet. And I'm keen to hear if you've done something similar.
Sure,
yeah.
And yeah, what we are trying to build is we have the drones that are flying around. So there's a lot of data that is being collected by them. So we are picking up use cases, industry specific use cases, and developing models on that. So that you fly a drone over an asset, and we derive the insights. Say if there are anything specific like faulty asset, or say there is a pipeline, oil or gas pipeline, then we detect cracks and geotag them so that it's easy for the monitoring agencies to go and repair before there is a bigger mishap that might happen. So and similarly for the energy heavy assets like solar farms or wind turbines, it's very difficult to have the accessibility for the humans, right? So that's where we are, fusing drones with data analytics and building models on top of that.
Oh, that's awesome. And is the model running on the edge, or actually you stream the video and detect it and do the inference in the cloud?
Yeah. So we do have a choice on that. We really don't have a choice on that sometimes, because depending on how important the asset is, the owners sometimes do not let us use cloud servers. So we have to do it on the edge at their site itself. Sometimes they're not that paranoid about the data, then we do it on the cloud. But yeah, we have both the solutions ready.
But is that running? Is the model also running inside the drone? Actually, not in the drone, yeah.
Yeah, no, not inside the drone, because otherwise, drones, it will basically kill the
battery.
Battery. Yeah. Currently, the flight time is about 50 to 60 minutes. If we have actually done the testing, it actually drops the flight time by 50% if we run the models on the drone.
Yeah.
So that's not a possibility right now.
Yeah. Wow, that's very awesome. For the awesome project. I really love anything with drone.
Yeah, thank you guys. Yeah. And your projects are really interesting also, like great projects, great initiative at your home. That's like a lot of things we do in office for work, but things that we are doing at your home is also tremendous. Yeah, thank you guys.
Cool. Thanks for sharing.
Sure.
Wow, see, all of you are very quiet, but you all have a much more interesting project than me. If nobody want to share, I'll share you something interesting here. Let me grab one of my latest project that I built just like a couple, last Christmas. Yeah. All right, let me see. Can you all see this? Yes. So this is my latest project I built during Christmas break, because I got bored, cannot go anywhere during COVID, right? So it's a robotic teddy bear. It has a motor here, so it has a servo motor that can go up and down and left and right. Yeah. It's actually my son's favorite teddy bear, and I got two of them, and I put one of them, turn it into a robot. Yeah. And here I replaced the eye with a camera. What is it? This one here. This one here is a camera. Yeah. Camera, and inside there is a servo motor that can actually move the head around like a living teddy bear. And inside here, behind here, look at the box here. Let me see. You can see here. Inside there's a gadget there. There's a Jetson. It's a Jetson Nano, and with a servo PWM motor, right? So all of the software running here, and what it does is really, this teddy bear can actually talk to my son Dexy. So talk normally like a human. And the way it works is, right, the camera actually passes through the video frame into the object detection model that constantly running to detect where he is. And also there is an image, the facial recognition that I built using DLIP framework to recognize if it is him. And then there is a microphone running here and a speaker. So the microphone will actually recognize his voice. And I stream it all the way into real-time voice recognition to get the text out of it. And I pass it into a GPT-3 model in the cloud. If you heard of GPT-3, it's an AI model that actually it's a generic large language model that you can use to build a chatbot that can actually respond to you just like talking to a human. It's super awesome. If you haven't tried before, give it a go. OpenAI.com, right? So I use it as a way to actually to give a brain to this teddy bear, so it can talk and respond to any question. Yeah. And it has a context. And of course, the response is actually a text from GPT-3, and I pass it into Amazon Poly to get the voice, and then I play it as in the speaker. So then this teddy bear can actually look at Dexy and keep tracking his head, facing towards him, and communicating with him. So if you are interested, I also can share you the YouTube link. Have a look. Maybe give you some inspiration for one of your startup ideas.
Sure, you saved the best for the last, huh?
So really, what I recommend you to have a look at the OpenAI GPT-3. That's a really changing the way we build AI tech and changing the perception of what AI can do. Yeah, it's an AI that you really can ask questions and respond like a human. Yeah.
Well, if there are no final comments, then thank you guys. Thanks for taking out time. It was really interesting, and loved your homegrown projects. Apart from some good knowledge that you shared, really excited on how we can leverage this. And thank you everyone for taking out time.
Thanks a lot. See you, everyone.
Bye.